Hey guys, it's Mr. Stark here, and I want to give you a quick, brief, but thorough introduction to box fill and the National Electrical Code article that pertains to everything you need to know about how many wires you can stick inside of a box. So let's take a look first here. We got Article 314, and specifically we're going to be dealing with Article 314.16a, all of these numbers, B, all of these numbers. So without going into a whole huge lecture on this, basically this article is going to tell you what code applies to plastic boxes with wires that go into them, what code applies to metal boxes with wires that go into them as well. So first, what you can see here is I've got a variety of different boxes here that at least let us know a certain amount of information. So this box, and this box, as well as this box, all have their cubic inch capacity listed inside the box. You're probably not going to be able to see this because of the camera and the lighting in here, but I'll just take this 2-gang box for instance, and once again, you're not going to be able to see it, but way in the back here, you're going to see how many size wires can fit in different sizes. So in this particular one, it says you can fit 12 number 10s, 14 number 12s, and 16 number 14s. And the cubic inch capacity you might be able to see, it says 32 cubic inches. So what do we mean about cubic inches, and how do we connect that to the wire size that then applies to that? Well, that's easy. So we're going to turn our page in the code book, and we're going to go to first, volume allowances required per conductor. So in general, when you're in the lab, we're dealing with either 14 gauge or 12 gauge wire for the most part, but this table gives you anything from 18 through 6 gauge. And what it's telling us is the cubic inch capacity of that type conductor. So let's just take 14 gauge for instance, and we scroll across here and we see that it's equivalent to 2 cubic inches. So with that being said, if this box said I have 32 cubic inch capacity, well then we could do some simple math and come up with how many of those 14s would actually be able to fit into that box without applying any of these rules on this page, because these rules do matter. Whereas the metal boxes, they don't have their cubic inch capacity listed on the box. So where we would find those cubic inch capacities, we're going to find that on this table, 314.16a, and it gives us the type of metal box that's in question, and then it tells us how many of what type wire can fit by simply reading this, and then it then tells you the cubic inch capacity of the box itself. So let's just take this for instance. We're going to look at the 4 by 1.5 inch round octagonal box, and it says that I have a 15.5 cubic inch capacity. Well, that would be this box. So this is an octagonal box. It's 1.5 inches deep, and it's telling me I've got a 15.5 inch cubic inch capacity. Once again, if my wire size that was going in there is 2 cubic inch, well, simple math says around 7 conductors can fit in there with nothing else going on. And there's rules. So let's get into the rules first. So we're going to turn back a page, and you're going to see some of the things that apply. What is a wire worth? Well, that's based on this article. Then they talk about standard boxes and other boxes. So that's basically saying metal or plastic. Box fill calculations, conductors, they want to know what the conductors are worth. Well, we know the conductors are on the previous page, which would be right here. What are these conductors worth? The other rules would be clamp fill. Some of these boxes have clamps. So if you look inside of this box, you can see in here there's got these little internal clamps shaking around in there. They come from the factory. Those are called internal clamps. Those are worth a certain value based upon the code. Some boxes have internal clamps, some don't. We're going to learn about that. Support fittings. this usually deals with light fixtures and ceiling fans. Those little brackets that come with those things, or canopies or whatnot, they're allowed a certain rule or exception. Device or equipment fill. Now we're talking about in these boxes or these, we'd likely be putting switches or plugs. Well, those have a certain volume cubic inch capacity as well. We're going to learn about that in the course. Equipment grounding. Well, how many ground wires can you fit in a box as far as calculating, and when do you have to calculate them, and how many? We're going to talk about that too. So as we start to go through some of these sections, mainly pertained within this first section of the code, 314.16, we're going to see from now on in every lab, well, we should be thinking about box fill every time we put something in here. So another thing to take note of, if you look at some of these covers, these plasterings or mud rings, this being a 2-gang ring, if you really look close, you might not be able to see it in this video, but right over there it says 3 cubic inches. So the code book is telling me that I can then use this to add to the box fill, which would increase my inside area, and it's going to give me more. I'll show you how to calculate that in class. Each one of these mud rings has its own cubic inch capacity. This particular one here, if you look, says 3.8. And of course, we also have our raised covers or mulberry covers. This one here says 4.5 extra cubic inch capacity. So in summary, we can find all these metal boxes, this being a octagon, a 4-inch square shallow, a 4-inch square deep, a 4 11/16, a device box. All of those metal boxes are actually found within this column here. We'll show you how to read those when we're doing the calculations in class 2. Plastic, obviously, they have their cubic inch capacity listed deep within inside the box. You have to look for it so you can see how many wires you can fit in those boxes. Those plastic boxes are not on this table. And once again, this table does not take into account plugs or switches or anything that you're adding that would be into that box. So hopefully this brief preview is going to get you ready to do a little bit of math on this, and you have to know these rules. So when I'm teaching this in class, you will be forced to memorize what all of these individual things are worth and how we equivalate that worth into wires, and that's it. We'll see you in class.